In our discussion about linear independence, the important thing that we started with was the definition of linear dependence, and then we looked at the definition of linear independence. To test whether or not a list of vectors falls in one of those two categories, you start with the equation obtained by scaling each of those vectors by variables, adding everything up, and setting it equal to the zero vector. That gives you a system of equations. And ultimately what we're finding is that whether or not that list was independent hinged on whether or not you had a free variable in the system. If you don't have a free variable, that means the vectors are linearly independent. And if you do have a free variable, that means that the list is not linearly independent, which means they are linearly dependent. All of this can be numerically represented by just taking the vectors you care about, putting them into the columns of a matrix, and then checking whether or not that rank of the matrix is equal to the number of columns, or equivalently checking that the nullity equals 0. So I've written a tiny Sage module that will do just that. Here, what I've defined is a variable called vectors, and here I've input a predefined list of a bunch of vectors. So you can change this yourself, put in your list of vectors. And then what the lines down here do is this third line will put those vectors into the columns of a matrix. And then we have 3 print statements. The first print statement will tell you what the vectors are that you input. The second print statement will tell you the reduced row echelon form of that matrix. And then the third line will tell you whether or not your list is linearly independent. So let's see whether or not the list that I've predefined here is linearly independent or not. So let's click Evaluate. Okay, so what happened here, the vectors that I care about here are the columns of this 4x4 matrix. When we do the row reductions on that matrix, we find that we have rank 3, so in the fourth column is a non-pivot column. That tells me that this list was linearly dependent because the nullity here equals 1. So the answer to the question of whether or not this list is linearly independent is no, that is not true. Now, what this is, like, what can we, say from here? Well, it was the fourth column that depended on the previous 3. The previous 3 columns were the pivot columns, and one of the theorems we stated in class was that the pivot columns are always linearly independent. So if I delete this fourth vector from my list, that should leave me with a linearly independent list. So let's delete that vector and then reevaluate. So I've deleted that fourth vector from my list. Now the matrix I'm constructing is 4x3 instead of 4x4. I only have 3 vectors in my list now. When I do the row reductions, I don't have a non-pivot column. Every column is a pivot column. So the answer to whether or not this list is linearly independent is yes. That list of vectors is linearly independent. So here we have a quick way to check whether or not any list of vectors is linearly independent.